This is the original program. It's a basic nested for loop style program. And what we want to do is modify the original program so that it creates a matrix B with the values of this. 1, 2, 3, 4, 5, 6 columns and 4 rows. So I'll copy this over here, and I'll also copy over the matrix that I want to create, and I will comment this out so I can execute this program without MATLAB objecting to invalid commands. And there were several things that we graded this program on. The first was noticing how many rows and columns there are. So in this case we have 4 rows, 6 columns, and then you should notice that I and j are in these positions. So j is in the first position, therefore j is going to represent the row number. Again, it doesn't matter what we call j could represent a row number or a column number. It doesn't matter what we choose. What matters in determining if it's a row or a column number is its position in the parentheses after the name of the matrix. So here we have j in the first position, therefore j is representing the row number. And so j should vary between 1 and 4, and I must be the column number, so that varies between 1 and 6. And then we're left with this problem. This will create a matrix that is 4 rows and 6 columns wide, and if I just do this, it'll create a matrix that has 4 rows, 6 columns, all values being 1. So let's verify that and execute. And I'm shown here all values are 1, and it has the correct dimensions. So that's the first thing we're looking for. Now, we have solved problems in the past where we had something like this. B of ji is equal to I, or B of ji is equal to j. So let's put in I and see if we can guess what's going to happen, just by plugging in a few values. So suppose j is equal to 1, and then I is going to vary between 1 and 6. So the first time we'll do this, we'll be doing b of 1, and then I is equal to 1. And if I is equal to 1, then this is equal to 1. And then we'll do this, row 1 still, column 2, so I is 2, and this is I, and this is I, so this must be equal to 2. And so what we would expect is that when we execute this command is that the first row should have values 1, 2, 3, 4, 5, 6. And let me verify that by executing. 1, 2, 3, 4, 5, 6. And now we can run this with j and execute it. And we get all 1s across the top and then all 4s across the bottom, which is pretty close to what we wanted. Now, to figure out what this is doing, I again encourage you to expand this out. If you're not able to do that shorthand inspection of the matrix like I just did, expand this out in the standard way that we have done before, where we'll do j is equal to 1, j is equal to 2, and then we do this, and so on. And then we do that for j is equal to 3 and 4. And then we need to expand this out. So I'll write out the first few steps. I is equal to 1, I is equal to 2, and then we'll do the other steps all the way up to I equal to 6. And I'll indent this just to make it easier to read. And then plug in values. So here j is 1, I is 1, b of 1, 1 is equal to j is 1 still. Here j is still 1, haven't changed it, I is 2, and j is still 1. And so row 1, column 1 is 1, row 1, column 2 is 1, and so this is consistent here. And then to figure out what happens for the second row, we could copy this and paste this, and the only thing that changed was j, and so we have j here, this will be 2, this will be 2, and then this is 2 as well. And so this is how you would figure out what's happening why this matrix is getting created. But now I'll assume that you got this that far, and then ask, how do we get this so that the first row is all 4s? Well, how about this? Instead of starting at J, we want this to be, instead of starting at 1 here, we want this to be 4. So how about if we do 5 minus 1, 5 minus 1, 5 minus 2, 5 minus 2. And that's equal to 4, and that's equal to 3. And to do that, we would just do 5 minus j, and then you can see if I had this being 5 minus j, 5 minus j, and again repeating that down here, then I get what I want. I get 4s in the first row and 3s in the second row. So I can execute that. And here we get 4, 3, 2, 1, which is what I wanted. Now to solve this second problem, I'm going to copy and paste this here. The first thing I want to do is to count downwards. And I did that problem already before, where if I had this as being I could sort of get this pattern. So let me just do 4j is equal to 1 to 3. So I want 3 rows and I want 3 columns. And now if I execute this, I'll sort of get what I want. Get close. I get 1, 2, 3, 1, 2, 3, 1, 2, 3. But I want to count down, and so I can use the same procedure that I used over here. If I start this as 6 minus I, what I'll get is a countdown. And again, you can verify that countdown by working it out through here, which I encourage you to do. So now I have 5, 4, 3, 5, 4, 3, 5, 4, 3, which is what I wanted. And I just need to put a negative sign in there, so I can just do minus or minus 1 times. Both will give me the same answer. Copy and paste this, and there we go. And again, you would solve this problem by first identifying the rows and the columns. That's the first part of the problem. And then just try guessing a few different things that you would put here. Try to get the pattern close. So in this problem, I said, well, the pattern close is this upside down, where it's all 1s, 2s, 3s, 4s. And if I can get that far, then it's only a small additional step to get it to go in reverse order, going 4, 3, 2, 1. And a similar thing here, if I can go 1, 2, 3, 1, 2, 3, 1, 2, 3, I can also do 3, 2, 1, 3, 2, 1, 3, 2, 1 downwards, and then I can just modify it a little bit to get the negative signs and to get it to count down from 5. Okay, in this problem we're asked to create this matrix, and this was an example. It's somewhat of a challenging one, and it was an example on one of the midterms, and so that's why I put it on here, so that you would have a chance to work it out ahead of time. But again, it was probably one of the more challenging examples. And to figure out how to do this, what I would do is to say, I would look at the equivalent set of commands that I need to do to create this. I would do b of 1, 1 is equal to 1, b of 2, 2 is equal to 4, b of 3, 3 is equal to 9. And so the pattern here is that these are always the same, 1 and 1, 2 and 2, 3 and 3. And then what's on the right-hand side is just the product of the row times the column number. And so now I just need to create a for loop. In this case, I'm just going to need one for loop because these are not changing. These are always identical. That executes this. and so I need to do 3 steps. For I is equal to 1 to 3, and then I can do b of I comma I is equal to I times I. End. And if you write this out in longhand, what you'll see is that it's doing exactly this. And if I haven't defined B before, the matrix B, put a clear statement in here, what I'll get at the very end is a matrix with that structure.